In this exercise, we'll solve an inequality that at first glance looks rather complicated, but we'll take it step by step and we'll get a solution. We see that we're solving for x, and the first thing I notice is that there are a lot of parentheses. So I'm going to multiply through to eliminate those parentheses, and I have negative 8 times 2x be negative 16x, plus negative 8 times 3 would be minus 24, plus 6 times 4, which is 24, minus 6 times 5x, which would be minus 30x, is greater than or equal to 2 times 1 minus 2 times 7x, which is 14x, minus 4 times 4, which would be minus 16, minus 4 times 6x, or minus 24x. Now once I have the parentheses removed, I combine terms separately on each side of the inequality. When we do this, it'll look a lot simpler. First of all, the x terms. Negative 16x minus 30x is negative 46x. Negative 24 plus 24 is 0. So the left side of the inequality is simply negative 46x. This is greater than or equal to 2 minus 16 is negative 14. Negative 14x minus 24x would be minus 38x. And you can see by simply moving step by step, we already have a much simpler looking inequality. Now let's add 38x to both sides of the inequality, and I have negative 8x is greater than or equal to negative 14. And now I want to divide on both sides by negative 8. In order to divide or multiply by a negative number when we're dealing with an inequality, we need to reverse the direction of the inequality. So dividing by negative 8, I get x is less than or equal to negative 14 over negative 8, or x is less than or equal to, simplifying, 7/4. Now this is an inequality. In order to write that as a solution set, I write it with set notation. The set of all x such that x is less than or equal to 7/4, or in interval notation, it's less than or equal to 7/4, so I go all the way down. There's no left limit, so I use negative infinity to 7/4, and I use a bracket to show that it could equal 7/4 as well. Both of these are ways to write the solution set of that inequality.